And the next speaker, hopefully we'll have a Q&A session after this panel is over. So the next speaker is Elena Kravtsova, the lead engineer photogrammetrist from Roscartography. As you know, Roscartography is everything for us. 32 companies, the only supplier. And now we're going to hear which geospatial products they produce. Elena, you have the floor. Hello. My presentation is about digital geospatial data of Roscartography. In the beginning, a few words about my company. First of all, according to the decision of the government of the Russian Federation, Roscartography and its branch institutes are the only executors to do procurements by Rosregistry. And having own hardware, highly qualified specialists, the Roscartography group of companies doing all sorts of geodesical and surveying work and mapping work. Also, we sell the digital products to build the Geospatial Data Fund. Roscartography group of companies participates in a major mapping projects in Russia. Some of them are the development and pilot implementation on the territory of Tatarstan Republic, cloud 3D modeling, urban maps of the 1 to 2000 scale, national project which started this year, Digital Economy of Russia. At the moment, under this national project, Roscartography is doing work on the development of the basic, highly precise spatial data framework to build a single cartography foundation, which includes 1 to 2000 scale for urban areas, administrative centers of Russia, and orthophotos of 1 to 10,000 scale for the territory of areas with high density of population. In 2019 alone, we expect to do more than 40,000 square meters for 1 to 2000 scale and more than 500,000 square kilometers for 1 to 10,000 scale. In the process of preparation for this project, we decided to use the classical aerial photography to get remote sensing data because this method proved to be quite efficient for us and economically justified in case of the use of modern aerial sensors. Roscartography owns a number of such sensors, among which are Leica MC3 cameras. Now, I will speak more about the project implementation that is shown on this slide. It was completed in 2018. This is the digital model of the Republic of Tatarstan. Under this project, Roscartography participated as co-executing agency to provide geospatial data such as aerial photography, digital elevation model, and 3D models. The results of this operation showed that technology was optimally used for the input data and subsequent application of these technologies in this project and subsequent projects as well. Now, for aerial photography over the area of about 20,000 square kilometers, which is about 1/3 of this total area of Tatarstan, we used DMC3 camera. As a result, we have acquired more than 10,000 images with 15 centimeter pixel size with 60 to 30 overlaying and almost 8.5 square kilometer size of the frame. We have done it for 1 to 2000 scale mapping, and the imaging was done in just 9 days, including calibration flights and repeated flights. For post-processing, we have used text map and complex photo mod applications for photogrammetrical work. A few words about the MC3 camera, which is a large format airborne camera. It's among its advantages. I would like to tell you that these are real pictures on this slide. It's mounted on this light aircraft, Beechcraft King Hire 350, during the actual photography project over Tatarstan. Technical characteristics of the camera are shown on this slide, which gives you a general idea on the quality of the acquired material. First of all, the productivity of this camera because of the size of the frame, and as a result, reduction in time and costs of the imaging, reduction of the number of images required for stereo model because of the wide frame capture, and the less time for geodesical and photogrammetric work, and for more efficient collection of data to build digital elevation model. And big memory block for storage of data, and the quality, of course, of images because of the broad dynamic range, which doesn't lose any details in highly contrast images, low noise of the CMOS sensor with a high quality in the dark places, and a limiting filter in panchromatic mode, which gives us very good imaging and the corners of the frame, and helps us with the seamless mosaics and small intervals between image capturing, which allows us to use the camera with high speeds, with high precision, resolution, and high overlap, and geometrical precision. High resolution images are generated through one single block of panchromatic, and there is no need to stitch the images. As a conclusion, the best application for this camera was the orthophoto plan building and stereo imaging of large areas. Next, on this slide, you can see the software which was in use to work with the MC3 images. It was the post-processing platform from Leica Geosystem called HexMap that allows us to quickly process the raw data of aerial photography, and of course Photomod, which we have selected as a basis to generate DMs and orthophotos, again with a high quality photogrammetric processing. The advantages of these two softwares are well known to you. I'm not going to go through the whole list. Once again, please note that this software allowed us to automate most of the processes, and there is a way to do distributed calculation, which again brings with that high productivity rate. Now, this slide is going to show two technological workflows starting from raw data to orthophotos. The HexMap workflow shown on this slide is subdivided into steps, which are united by the so-called perspectives. And I start from the uploading of the raw data to generation of the data free of distortion, radiometrically corrected. We use special calibration data and flight trajectory data and radiometric rectifications. And this data can be used for direct application of photogrammetrical systems, which we did. This data with the go-to systems of Photomod are then uploaded for the generation orthophotos and DMs. This is the workflow of how we develop the digital elevation models, and you can see it's quite classical, conventional. Of course, it can be customized to the needs of the camera and the project itself, such as the relief, landscape, number of buildings, and with the correctly input parameters. Most of the stages are done automatically with some manual editing required. This slide shows a more general table that shows that the use of data from DMC3, the software HexMap and PhotoMod, can together highly automate the process, high speed of work, and good high quality and precision of the generated orthophotos. Based on this project, you can see how the project can be organized by combining quality and speed. As a result, we can make more work in a shorter period of time. And in conclusion, a few more words about Roscartography. That first of all, the scientific and technical progress places great demand on geospatial data, and Roscartography group of companies creates optimal conditions for the development of technological potential, and it expands the range of digital geospatial products for public sector and commercial users with an up-to-date and modern cartographic and geodetic basis. Roscartography joins the company, constantly introduces new technologies for creating digital geospatial data, and at the moment we're considering the possibility of using UAVs together with a piloted aircraft, which will help us get the required basis for the digital elevation model for, say, remote, inaccessible areas, small sites. Also, we're introducing laser scanning technology that will help us do highly detailed topo imagery and create a broad range of digital products based on that. And as a result, we equip workstations with modern computer equipment and high-speed optical communication systems. We introduce modern software from major companies such as Rockers, Hexagon, Trimble, and others, and we attract more highly qualified specialists. And in conclusion, I would also like to say that because Roscartography JSC implements so many projects, and we plan to implement as many in future, we're considering more fruitful collaboration with the company Rockers in future. Thank you. Thank you, Elena. Will there be questions? We're still within our time. We have time for a general Q&A session. So will there be questions for the speaker? Traditionally, Olga will start with the questioning. The mic should be on. Again, the question about which are the results of the work, which data of the resultant from the work of Roscartography are open for the civil society. Do you have plans to make them open for the society? Again, I'm at a loss to answer your question about the openness of data. Indeed, it's hard to answer this question by Roscartography because the customer of this work is Rosregistry, and the owner of all this work is Rosregistry. It will be the question for Konstantin, I guess. Would you like to comment on this? In fact, I will refer or defer again to the caveat that all this work does exist. I mean, all this project goes into the Federal Fund of Spatial Data, and the information about which area has what images. We have this information open access to. So to get this information for state needs, usually it's done free of charge. You sign an agreement with the owner of the State Fund of Spatial Data. That will be the sub-company of geodesy cartography, and you get data for that. For commercial companies, so far, the geodesy cartography law implies commercial sharing of data. So metadata are openly available, but the actual data can be acquired for money. Okay, thank you once again. Question for Elena. Are there any questions for Elena here? Elena, you were talking about a large-scale mapping of residential areas as part of the national project, right? But the actual mapping of the whole territory of Russia, is it in plans, and if yes, in what scale? Or there is no such plan? Well, I'm sure that there are such plans, but so far, I guess it's a long-term program split up by years. Now we're working on this area, then we'll capture another area, and onwards like that. Thank you. Can I help Elena answering this question? There is a plan from 2019 until 2024 with a clear description and numbers and areas and end results on mapping down to 1 kilometer.
Winter from Smart Spatial China. As quality and performance in your PowerPoint, you say that creation, also transformation images and DTM, the speed, the processing time is 2 months. How many photo model? The question is that how many photo models have been used for the project?
4.
4. Okay, thank you. LED version or look version?
Pardon again.
4, 6, 4. 6, 4.
Yeah. Okay, great.
Сетевая.
Okay. And one more question is that have you processed oblique images?
Наклонную съемку обрабатывали, вот наклонную съемку.
Нет. No.
Thank you very much.
Ну, поскольку коллеги вот...
Since colleagues were starting a discussion, I wanted to comment on Yelena's presentation. When we talk about processing times and so on, we typically use hardware for reference, because a lot of photogrammetric systems highly depend on computing power. If we say 2 months or 3 months, that's how much it took for processing, it is relevant to mention the type of computer with the number of cores and so on and so forth, because the processing time largely depends on the hardware capabilities. That's why we had this question from Human Say. Any other questions? All right, thank you, Elena.